In this video, we're going to talk about vectors and scalars. So note 6.6, it's the last section before we start reviewing for your unit test. So to start off, some vocabulary words here. Vector is a quantity that involves both magnitude and direction. It's going to need both magnitude and direction. And for us, this vector is usually going to be either bold, so written in bold, or it's going to have an arrow above it like this. That shows that it's a vector. Okay, in the notes we're going to just show the arrow since it's kind of hard to show the bold part, but know that if you're looking at your textbook or another worksheet, if it's bolded or has the arrow, those both mean it's a vector. Then I have scalar, and these are quantities that involve magnitude only, no direction. Okay, and for us, the scalar is going to be essentially a number that's multiplied by the vector. So we are going to apply this scalar to the entire vector. We're going to be multiplying by it. Then we have a directed line segment, and this is a line segment to which a direction has been assigned, consisting of an initial point A. So if I'm drawing this out, I have an initial point, that's where it starts, a terminal point B, so it goes all the way to B, and then the direction that's been assigned. You just show that we're going this way, for example. In this case, I could name this, if there was another letter here, like the letter U, I could say this is vector AB. Again, I'm using the arrow, or vector U using the arrow. You could also see these as just bolded letters. That would also show that it is a vector. Okay. And then magnitude. Magnitude is not a new term for you. You should have seen something similar in geometry, but in geometry we call it the distance formula, and it's essentially the same thing, except this time we're going to simplify it to be applied just with vectors. So as a quick refresher, the distance formula, which you should be familiar with again, distance formula is usually used with, or actually it is used with 2 points. So you would have 2 points, x1, y1, and x2, y2. Okay, we're not going to be using the distance formula that you're used to. I just kind of want to make that connection. So the distance formula for us was x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So you would essentially find the horizontal distance, so your x's, and then square that. Then you would find the vertical distance, so your y's, and then squared that, and then took the square root, and that was your distance formula, right? So we are going to be applying this distance formula, but now we're calling it magnitude because it's specific to vectors. And what we're going to do with these values, the x squared minus, or x2 minus x1, sorry, we're going to call that something else, and you'll see we're going to refer to this as A, just essentially combining it and making it one letter, okay? And then we're going to take this, combine it, and make it another letter, and you'll see that here in a second. That's going to be B for us. It doesn't really matter which letter we use. We're just trying to get you to understand that with vectors, you are not going to be given the 2 points like you would in geometry, for example, to find the distance formula. Instead, these numbers are embedded in the vectors, so we're not going to need to subtract the difference between x's and the difference between the y's. Instead, we're just going to square it and then add them and find the square root. And we're going to do some of these problems here in a moment. I just want to get through all the terms and definitions here. Okay. Now, we're going to be talking about vectors in terms of I and j. So the I is going to represent the x values as if you were moving in an x and y axis, and the j is going to represent the y values, so going up and down. So think of it as I as horizontal, left and right, j as vertical, up and down. Okay, so in this, if we have v, so I'm going to just add the arrow here because we're talking about a vector, and then so vector v and vector w are here. We are going to be adding, subtracting, and then multiplying the vector by a scalar here in a few examples. And so I want you to know that these are all vectors. I know they're not bolded, so you could go in and include all those arrows if you want, but we are talking about the vectors. So two ways you can think about the formulas. If I'm asking you to add two vectors together, so I'm asking you to add this vector, so I'm looking at this one here, and this vector, I want you to think of this as combining like terms. So when we're adding vectors, we want to look at the I terms. We're going to add the coefficients and simplify, and then we're going to look at the j terms, add the coefficients, and simplify. The way that it's written here may work for you, it may not work for you, so I'm going to write it as two different ways. But essentially, what this is saying is that we're taking the coefficients of both i's and simplifying, and then we're taking the coefficients of the j's and simplifying. Another way you could think of this, think of you adding like a sub 1 I plus b sub 1 j. So you're taking this very first vector, that's what I'm writing, and then I'm adding onto that the second vector, so a sub 2i plus b sub 2j. And then if this was just a regular problem with x's and y's, all you would do is combine your like terms. So I would take my a's, these are like terms, and then I would take my b's, these are like terms. I would add them up and simplify. Okay, so again, we are going to do some of these examples in a moment. Just kind of wanted you to see that. Similarly, with subtraction, we're going to take both vectors and subtract. So here I'm going to write it again. So another way to think about it would be taking a sub 1i plus b sub 1j. And I know this is subtraction, but again, I'm just taking the vector and replacing it here. Okay, so I know it's subtraction, the subtraction comes in here. We're going to minus the other vector, a sub 2i plus b sub 2j. Okay, so with subtracting, we just have to make sure that we're careful in this negative, the minus, that we distribute that through before we combine like terms, right? But once I have that done, then I will look at my a's and know that these are like terms. And then I have my b's, and those would also be like terms. Okay, and then I would simplify. Again, just be careful with that minus. Make sure you are distributing out to everything. And then the last thing that we have here on this part of the notes is this k. This is going to be your scalar. Okay, so essentially if you are multiplying a whole vector by a scalar, you would just make sure you distribute that to the entire vector. Okay, and we're going to do some of these examples in a moment. All right. So in the vectors, A is the horizontal component. So again, horizontal means, think of your x's. B is going to be your vertical component. So think of that as your y's, so going up and down. And if I were to ask you to find the magnitude of a vector, and the vector is going to be written like this. It's going to have an A and a B. So again, your horizontal and your vertical. Whichever one is paired with the I, this is going to be your horizontal. So that's why it says A is a horizontal shift. And then whichever one's paired with the J, this is going to be your vertical. So again, that's why it says B is the vertical. Okay, so here is the general formula for finding the magnitude. The magnitude is going to be A squared plus B squared. And these are just A1 squared, B1 squared. I'm just keeping those letters consistent. And then you're going to take the square root and simplify. okay? Something important to note that when the vector looks like this, we are going to remove, so make yourself a little side note here. We are going to remove the I and the J in the magnitude formula. So we are not including the I and the J in our formula. They are just there to give us, again, that horizontal component and the vertical component. It's telling us which way to go, but we are not including the I's in the actual magnitude formula. Now, this is the second magnitude formula that I've introduced. The other one is up here at the beginning. We said magnitude was essentially the distance formula. So one more time so we're clear, the distance formula and magnitude are the same thing. What we're doing here is simplifying it out. So distance formula we use when we're given 2 points, which is not going to be the case in this section. We are not going to give you 2 points. This is just to show you the connection that we're making between the two, distance formula and now the new magnitude formula that we're showing you. Instead, what we're doing, because the vector is given to you, we're skipping the step of subtracting the values before we square them. We're replacing that with the a value, in this case for the x's, and we're replacing that with the b value for the y's, okay? So we're skipping that step of finding the difference between x's and finding the difference between y's. So let's do a quick example of what it's going to look like more for you. Okay, I could give you a vector here. Let's see. Let's call it v is 3i minus 2j. And so if the problem says, okay, find the magnitude, here's what you would do. This is how you show magnitude, okay? 2 bars next to that v, because we're talking about the vector v. So if that's shown on a quiz or a test, the vector letter with the 2 bars, it means find the magnitude, okay? And this is a formula for the magnitude right here. So identify your a value. In this case, my a value is 3, and my b value is -2. Bring that negative with you. If that was a plus, you would make it a +2. And we would just substitute into this formula right here. So a is 3, we're going to square that, and b is -2, we're going to square that. Okay, so 3 squared is 9, -2 squared is 4, which gives me the square root of 13. So the magnitude of vector v is the square root of 13, and that's your answer. We do want you to simplify radicals. So if this was a radical that would simplify, you would break it down and take anything out that's inside the radical, that's a perfect square, and simplify. So if you need a little bit of help with that, let us know, and we'll help you out, okay? Now, one more thing on this side of the notes before we go to practicing adding and subtracting those vectors is the following formula. So if I say kv equals, okay, so if there's a k, we talked about k being a scalar, and so we're going to multiply essentially the magnitude of vector v by whatever k represents. So this one will make more sense once we do our actual example here. So for example, we can say the following. So we're going to say find this where your vector u is, let's say, 2i minus 5j. Okay. All right, so what this breaks up into first is k, the scalar, is always going to be the absolute value. That's what these 2 bars mean. One set of bars means absolute value. 2 set of bars means magnitude. Okay, so if I were to rewrite this, I would say that I'm finding the absolute value of the k, so -2, and then I'm multiplying it by the magnitude of my vector, in this case u. So let me find the magnitude of 2. First, the absolute value of u, sorry. So the absolute value of negative 2 is just going to be 2, okay? And then I'm going to multiply it by the magnitude of my vector u. So looking at this vector, I know that I'm using the magnitude again, going way up here again. Magnitude formula is going to be taking a, which in this case is 2, squaring it, and adding it to b, which in this case is negative 5, and squaring it. The 2 is going to stay there. Think of this as, again, the scalar that just goes in front of, in this case, the magnitude. 4 squared, or 2 squared is 4, plus 5 squared is 25. So 4 plus 25 is 29 in the square root. Again, I try to simplify that if I can. Otherwise, this is just going to be my final answer. Okay. All right, so I know that was a lot of definitions. Let's go ahead and put this to practice, going on to the next page. And in this next page, we are going to add and subtract these vectors. So it depends on how you want to write them out, whether it's the first formula that I showed you in the notes at the beginning, looking at just the coefficients, or if you want to think of it as combining like terms, we're just going to do that, both examples, okay? So starting off with adding, we're adding v plus w, so I'm just going to write, all right, if I'm doing v plus w, I know that I'm taking my value of the v vector, so 5i plus 4j, and I'm adding it to the w vector, which is 6i minus 9j. Okay, so these, again, I'm not putting in the arrows every time, but these are representing vectors, the I and the j, their direction here. So just combine like terms. So I have 5i plus 6i is 11i, that's a vector. And I also have 4j, and then plus a negative 4j. So be careful there with your negatives, right? If I'm 4 and negative 9 is going to give me a negative 5j. And that's my answer. I just have to combine the like terms. I'm simplifying these two together. If I'm subtracting the 2, it just matters that you keep it consistent with the order. So if you're taking v and then subtracting w, make sure you are writing it in that order. So in this case, again, vector v is 5i plus 4j minus 6i minus 9j. So with the negatives, just be careful that you are paying attention to those negatives. In this case, I would think about it as distributing, or once you're combining like terms. However you want to think of it, just be careful, okay? In this case, I have 5i minus 6i. So that's a negative 1i. And then I have 4 minus a negative 9. That becomes a plus. So it's 4 plus 9 essentially. So that's plus 13j. And again, these are vectors, so I need to add the arrow. You could include the 1 there, so you could technically say 1i plus 13j with the vector above. You don't need to, either one will be fine, okay? So whichever one you want. Now I want to add here that on the homework, it's going to ask you to, for example, find the magnitude of 2 vectors being added up. So you're going to have to add the vectors first, but then go through and actually find the magnitude. Remember that anytime you see these 2 bars here, that means find the magnitude. So that's when you take the square root of the a and the b, square them, and then add them up. So if I were to do that on this example, for number 1, I would get my answer first, so add them up, and then find the magnitude by taking the square root. So on examples 5 and 6 on your homework, for example, it's going to ask you to find the magnitude of the two vectors being added up. So don't stop just by adding them. Actually go through and find the magnitude. Anytime you see those two bars, that's what that means. Okay? So let's go ahead and do example 2 now. Example 2 is dealing with a scalar, so it's asking me to find 6 times the vector v. So that means I'm going to write down the vector, and I'm going to multiply the 6 through. So 6 times 5 is 30, that's the I, plus 6 times 4 is 24, that's the j, so that's my answer. It's that simple when it's just multiplying by a scalar. Same thing with the -3. It's asking me to multiply the vector, -3 times vector v. So that means I'm going to multiply -3 by everything that the vector is represented by. That means I get -15i minus 12j. All right, example 3 kind of puts it all together. So it's asking me to multiply 4 by v. So it's asking 4 times v and then subtract 2 times w. So that means I'm going to take 4, multiplying by the value of vector v, 5i plus 4j. And then I am going to subtract 2 times the vector w, 6i minus 9j. So go through and simplify those. So 4 times 5 and then 4 times 4, 20i plus 16j. And then that -2, -2 times a negative becomes a positive. And then go through and combine your like terms. So then I have 20i minus 12i gives me a positive 8i. And then 16 plus 18 is going to give me 34. Okay, so that would be my final answer for this. Again, if this was on your homework and it was asking you to find the magnitude, it would have the two bars. So if it said this, it would mean to do this first and then find magnitude. Okay, so be careful. If you don't do the entire thing like on a test, you're not going to receive full credit. So make sure you're answering the whole question. Now the last part of this, we're going to need the unit circle for, and at least knowing the values of the unit circle. So when I'm asking you to write a vector in terms of its magnitude and direction, we're going to need a theta and angle. And this is going to be an angle drawn in, an opposite angle drawn, a standard angle. So this is a formula that you're going to need to memorize. This is not on your golden ticket, so please memorize this. We are going to give you these pieces. We're going to give you the magnitude of the vector, and we are also going to give you an angle. That's the information that's going to be given to you. Then you're just going to put it in the formula and use the unit circle for those values that you're missing. So let's just jump right into the example. So the type of problem is going to say to write the vector in terms of I and j. So your final answer should have I and j in it. Okay? Again, we give you the magnitude of the vector, and we give you an angle. And then all you do is put it back into the formula. So make sure you use the formula as it is. First thing in the formula is the magnitude of v, which in this case is 20, times the cosine first, and then the angle is 120, and this is I. Okay, so I'm just following this formula, going through it. Then it says plus, again, the magnitude of angle or of the vector v, which is 20, times sine of the same angle, and then j next to it. So remember we said I is the x values just like cosine, j is the y values just like sine. So that's another way to help you memorize which one goes with which, okay? Now, we need to figure out what the value of cosine and sine are at 120. So I'm going to draw a little sketch here. If I was to make the angle 120, that would put me over here in the second quadrant. And whatever memorizing method you use, you need to know that that's at -1/2 and then square root of 3 over 2. This is my x, this is my y, therefore this is cosine and this is sine. Okay, so I'm going to replace my cosine of 120 with a negative 1/2 because that's the value. And then I'm going to replace my sine of 120 with square root of 3 over 2 because that's the value at 120. And then you're just going to multiply these together. So 20 times negative 1/2 gives me a negative 10, and that's I, plus, and then 20 times the square root of 3 over 2, this is technically you multiplying straight across and then simplifying this fraction, okay? So that simplifies to 10 square root of 3, and then the j right there. All right, let's do one more example here. So again, we are going to give you the magnitude already, and we're going to give you an angle. So all you have to do is memorize the formula and use it. So formula starts off with magnitude. So 4 times cosine of the angle, 240. And then this is I. Again, cosine and I both represent x's. And then magnitude again, so 4. Sine of the exact same angle, 240. And then this is j. So draw your picture if you need it. 240 would take me all the way over here. I know this is a 60-degree reference angle, so my point would be at negative 1/2 negative square root of 3 over 2. So this is my cosine value, and this is my sine value. Remember, x and y. So moving along, I'm going to replace cosine of 240 with a negative 1/2 here. And then the sine of 240, I'm replacing with the negative square root of 3 over 2. Go through and simplify, so multiply these through. 4 times negative 1/2 is a negative 2, and that's the I. 4 times negative square root of 3 over 2 is going to change that to a minus, and that's going to be 2 square root of 3, and that's my j. And this would be my final answer. So again, for next chapter, you're going to need to know your unit circle for sure. So this is a good way to kind of bring it back and get you thinking of those values. Make sure you have it memorized. Remember to jump back on that call if you need any help. Let us know what you're still having trouble with.